I'm going to spend the majority of my time is talking about our fab and how we make our wafers here. And we also have the testing and packaging piece of it in our ATM plants, but that would be a future conversation. But let's just get started with who I am and why I'm at Intel. I was brought into Intel to help with digital manufacturing, because as Intel, we've been running our manufacturing practice, the IDM 1.0, for a while, and now that we're producing silicon for third parties, they're bringing in different tooling and equipment. For the past in Intel, we've been very fortunate to develop very customized proprietary software and proprietary tooling to manufacture silicon. Now that we're bringing in third party and we're manufacturing silicon, they have their own tooling, equipment, and software requirements. So there's a lot of lessons learned there. And what we're doing is we're taking those lessons learned and, with the complexity of that, offering it to the market and simplifying it through commercial offerings. So hence why I'm in the room with our partner Red Hat, because we use a tremendous amount of Red Hat in our fabs and in ATMs, as well as taking a look at how we can start to offer that to digital manufacturing, as you have that level of automation, all the tooling we know, and then you have the enterprise system. Because as I'm going to expose, we reached an inflection point at Intel where our production was masked with it was maxed out, or we reached a point where we had to get more information to increase our production levels. So that's where I am. I bring in the enterprise systems, and then I help commercialize and offer the software as well as services to customers to help on a digital journey to factory 4, 5, 6, whatever the term is today. So what I thought is, later on today, we're going to go, Andreas, with the workshop, is we're going to go through some ideation. We're going to start to think about what's possible in Factory 4.0. What are some of those goals, top or bottom line, that I'm trying to affect in, or you guys are trying to affect in your organizations, and what's possible, and what technology could I apply to make that possible, either drive top or bottom line in your organization. So I thought, to get things started, well, let's take a look at what's possible at Intel, is to take a look at where we've been, where we're going, and some of the success. Because as I visit customers across the globe, we hear Factory 4.0, we hear CVML, what's the generative AI acronym A, B, and C, but the bottom line is how does it affect my production? Is it going to improve my quality, my performance? Am I going to be able to get more product out the door? What does that really mean to me? So that's why I thought I'd take some time, is to show you guys what we're doing at Intel, what's possible, and then also what are some of the results of Factory 4.0. What does that mean when you digitize your environment? What are the benefits? Because I can tell you, at Intel, we have a tremendous investment into our manufacturing from a digital perspective. We have 10 fabs throughout the globe. We're expanding. We're going to have about 15 up here shortly. And to give you a size perspective, if you've been to Disneyland in the U.S., the fab in Ohio is about roughly 20 times the size of Disneyland for our existing silicon and for our new partner silicon. So that's a real hard sea to navigate there. And then also it's the navigation of around 16,000 independent vendors to produce our silicon, right? So how do we navigate and make sure that all of our supplies are inbound? How do we make sure with scheduling and everything else that we have that under wraps? And it's very complex, and that's another reason why we're coming together as an industry. So when you look at these digital capabilities, you don't have 100 people to go to. You have a coalition to come to, and its support in software, all managed through that coalition that we're going to get into here a little bit later. But another thing is we run a lights out fab. Ours, it's a little unique because it's a clean room. You need to really keep dirt and debris out, and honestly, Nobody enjoys being in a bunny suit for a long time. Duncan, you can raise your hand, right? And it takes about roughly, this is a US reference, about 20 football fields to produce a piece of wafer. And there's no human involvement outside of exception, because we managed through exception. And how did we get there? We had to get there by having real-time data of what's going on in flight in our production process. And at the speed and the volume we run, we can't look at everything. We have to be aware if a control limit is off or a parameter is off, and we can automatically change the recipe in flight or get ahead of that, right, at the speed we maneuver. And that gives us the ability, the only people that are on the floor are doing routine maintenance on control limits or machines that could not be adjusted remotely. And from a remote perspective, we have a remote operations center that, 20 years ago, Duncan, we had 4 people to each machine, and now we can manage 400 machines with 1 person through exception. And this is possible because we have the data at real time at what's happening in production. Was it an easy journey? Was it quick and fast? No, but the benefit of having the remote operations, and even in COVID, we were able to manage our factories from Arizona, an entire factory. It's the first time China's outsourced manufacturing to the US, right? So it was a pretty amazing feat there, as well as some of the other investments, right? It talked 16,000. We're spending an enormous amount of money on the technology, but if we don't spend this amount of money to digitize every year, we're not going to be able to keep up with our goals year over year, and we're not going to be able to keep up with our production. So as a snapshot, Duncan, you can probably relate to this, is looking through how we used to run everything manual, paper entry, people at the physical stations, people at the physical controls and the machines, and a lot of manual human intervention. And it's not that we replaced or we downsized or we got rid of the controls engineers, as they were elevated into positions at Intel to understand how they could digitize, how they could either go into a sales organization or lead an engineering organization. They were able to take more time out of their day to increase production or run some quality initiative, right, in our factory. So it's not that this technology is going to replace individuals, it's going to upskill people, because they're going to need to learn new talents, which is going to provide more value from an individual perspective to an organization, as well as an organization to an individual. And then we look at where we're at today is a fully autonomous factory. And what you see here is our FOUP, which carries our wafers, which back in the day you could carry a wafer, and now they're a couple 100 pounds a piece, but it's all picked up, run, drop into a station and another station. And what you'll notice through this video is, where are the people? You eliminate the people and the dirt and the debris within the factory in all of these different machines. And again, this is about 20 to 30 football fields of material movement and decisions and controls, because if a FOUP goes to a station and it's within the control limits, it'll produce that piece of silicon. If it's not within the control limits, it'll say, hey, can I adjust my recipe in flight and produce within spec product, or do I need to switch off to another station and bring that station down? But imagine if one of these stations is down, the red light is off, a person in another room in another plant is already, through AI visual inspection, already bringing that cell or that station in line back into control limits. And it's an eerie thing to walk through the factory. I had a customer tour in Chandler last week, and the customer, large automotive manufacturer, walking through a lithography process, and the machine behind us turns red. and nobody turns around and looks at it, right? It's all, everybody ignores the light, and the people at BMW brought it to our attention that, hey, it's red, and a minute later it just turns green. And then we walked them into our remote operations center and showed how the operators can actually bring in the different processes back online into control limit. It's a lot of work on the front end because you need the data, you need the CVML, you need the models to get it working, but it's the benefit that really pays off in the long run. And as we'll talk about in the ideation, because you talk about technology, but what does it mean to the business? What are the top and the bottom line, the benefits at the end of the day? If I'm going to make this capital investment, what is it going to mean to my organization? And we'll take a look at that, but this is kind of a food for thought chart. This is our journey. This is what we share with you, our customers, is our journey. We didn't just wake up one day and get everything right. We have a lot of black eyes and bruised chins going through this process. And what we're doing is we're exposing a lot of this to the industry because we realize the path to Industry 4.0, there's a lot of delays, a lot of challenges. So if we can take pieces and parts of this process and commercialize it, and through services and technology offer that to the market and increase the adoption rate of transformation, that's a win for us at Intel. That's part of our IDM 2.0 strategy. And from a raise of hands in the room, how many people are still recording quality or OEE on paper in the room? And how many people have recently installed an MES system and they're struggling with connecting that up to an enterprise system and understanding the value of why? Because we started with paper and the traditional MES, and we had to create a middleware system because we reached a point where there's only so much information we could get from our edge machines. We call them station controllers. And there's a point where we said we can only go so far, and then we said, well, we want to start implementing SPC, and then we want to eventually start to invest in some advanced process controls. But then we said, well, we really need to dip into some other systems to make that happen. Some manufacturing execution systems, some yield, material management systems. And that's where we really structured with the middleware and really defined an architecture of getting that edge real-time data into the enterprise system today. And the benefit of that is we came to a point where we had to merge our OT departments and our IT departments because we found we had the same service lines duplicated in OT and IT. And there were a lot of projects that IT was doing and OT was doing and a lot of delay. And so now today, all of our staff as part of operations sits on IT. And any projects approved, there's members from OT and IT together. And that was a huge saving at Intel as well as a delay. And it's just the organic learning and nature of the organizations joining together because now each of them know their own domain and then their collective domain of the items that they're running through. And then the biggest value that we have is we have the actual real-time data, and our systems and machines are cloned exactly across our factory, so we have common data sets and common knowledge, so we can quickly run AI against it, right? Because that's the challenge with any digital factory or digital twin out there. It's okay, great, I have data, but it's older than an hour. Okay, how am I going to operationalize data that's an hour old? You know, if I go to a plant manager and I go, yeah, I have a report from last week, and look at me silly, like it's not even on shift, right? It's hard, and that's where you get into these conversations of what data do I collect and how do I operationalize it? Because certainly historical data is good to pinpoint places to start collecting real time, but then what is the appropriate data that I'm collecting that I can operationalize, right? So that's a big look in the roadmap, and that's where we have our material movement, our material handling, and then also in the digital twins, and we can replicate that. And then we ask ourselves, well, what's a result of what we call it Intel copy exact? Because we have the same station controllers, we have the same software, we have the same middleware, pretty much parameters and configurations at our facilities. And if you look at where we started is, in Oregon is our test facility. That's where we start all of our new R&D and testing on newer products. The goal is if you have the same equipment and machinery, same people and training at the factories, the yield's going to be the same, right? It's the same thing. You walk in, the look and feel is the same, but when you start to see your fabs, before you have that real-time data, before you have that historical data, before you collect and normalize it, you look at these deviations between the factories, those aren't rounding errors. Those are hundreds of millions of dollars of loss. And then how do you get that under control? You get it under control by the real-time data and the integration with your enterprise systems, and then this is the result of our copy exact program. And you look at the deviations between our factories and our plants, and that's a huge savings at Intel, because we have to have the assurance outside of environmental conditions across the world that we can produce the same amount of yield within our fabs. And this is kind of the goal of digital twin and data, is you can look across the board from a macro perspective and really start to trigger in. If something's going south, that's money just going out the door, and then you can double click in it with some of the generative AI software we have and quickly understand what's going on to get that back into control from a macro and a micro level within Intel. And some of our constraints are, you look at year-over-year improvements on yield, and everything gets tinier at Intel and more complex. So we can do about a 4% yield year over year with the complexity. And the only way we can do it is by having the data, having copy exact, because when we put it into R&D, we can quickly trend and we can understand where the issues are today. And then from the workforce, we can have our people to develop the tools with generative AI and understand and start to go through quality, and they can start to spend their time, instead of rushing to fix things, to say, how can we improve a process? How can we put things in place? How can we create other services inside of Intel? And to take a look at, I skipped the slide there, but to take a look at this is, we have tons of white papers it's called IT at Intel, published on how we do a lot of things. But the reason I'm in the room and the reason for the digital manufacturing group is to find partners, how we can come together, reduce the complexity, and quickly show you top or bottom line numbers on the investments in the industry. And it's even our goal to collapse some of those 16,000 suppliers and reduce it, right? Because what we don't want is the industry to start bringing out these capabilities, and now it's 20 different players you have to manage per factory because of the technology is different. No, let's take another approach on it. If we need a yield optimization or a quality or some other goal that we're setting, it should be a coalition of partners that supports it, and it really easing that transition in for the industry. And that's where I come today, because we say, wow, I've seen all this cool stuff from Intel, the real time, the historical data, and this is where the market is today. You have a lot of data, and it's, what data do I collect? Where does the data go? It's very fragile. How do I operationalize the data? Because they're telling me, if I put this one thing here, I need to configure it here, and then I need to manage it, and then that was a career limiting decision because I didn't figure that out properly, and it affected production. So what we're really doing is, there's a lot of distraction and disruption here. What we're trying to do is through AI and some modeling and standardization is really cleaning it up and cleaning up the data that you're organizing. So if you're looking at yield optimization, quality, process controls, or even moving into advanced process controls, it should be organized and collected and then also offered and supported through the partner channel or even OEM and ODM. So that's one of my core roles here at Intel, is to recognize that and work with the industry to collapse that and reduce some of the complexities there. And another thing my organization does is we work with partners, host formal workshops where we go through, and we can even bring you into an Intel fab. We can bring our quality experts, our material handling experts, our inventory planning experts into a room and really talk about what it meant to Intel, the value, and then bring those level of experts into your organizations, and then we can start to lay out a plan and then even run financial analysts on that plan to say, hey, if we're going to make an investment in this capability or this feature, let's really get a good foundation if we have the right sponsorship and it's going to make sense financially in our organization. So hopefully we can lead you guys to some of this today during the ideation, and then also as a takeaway, love to spend time with each one of you guys to get you know you guys better and to understand some of your challenges.